Folks, here's a question about section 3.2, and it's question 29 in the textbook. That doesn't correspond to the number in my math lab, but it's one of the my math lab homeworks from our section 3.2. In this problem, we're asked to find the derivative of the function, that is, find f prime for f, where f is given to be this function. Now, one thing to keep in mind is at this point we have not learned the derivative rules, and so we need to compute f prime of x using the limit definition. Once we do so, we're asked to evaluate or find an equation of the tangent line to this graph at the value where x is equal to a. So let's first compute f prime of x. So f prime of x can be computed using the limit definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. Just as a reminder, if you're having trouble seeing this, this is your slope formula here. This is our y2 minus y1 all over, and then here we would have had x plus h minus x, and so that's our x2 minus x1 in the denominator. So hopefully that looks like the slope formula to you. And then that's the slope of the secant line connecting 2 points on the curve, but then we're going to let h, the distance between the 2 points, go to 0. So that said, we then jump into actually computing the limit. That's the limit as h approaches 0 of 3 all over 4 times the quantity. Oops, hang on folks, that's erasing that. This would be the limit as h approaches 0 of 3 all over 4 times the quantity x plus h plus 1 minus 3 all over 4x plus 1. So just as a reminder, what have I done here? I've replaced the f of x plus h with this entire expression here, replacing the value x in the expression with x plus h. That's what I've done there. And then in place of writing f of x, I've written this expression here, and that's just the definition of the function. And then we have this, oops, that's not going to save that. Then we have this all over h. So there's many routes you could go to tackle this problem. However, my advice, and by advice you really ought to do this knowing what's coming down the road with some other problems, is to go ahead and multiply by the LCD of these smaller fractions. So I'm going to multiply this by 4 times the quantity x plus h plus 1, that's one of the denominators, times the other one, which would just be 4x plus 1. So the way I want you to think about this is I'm going to multiply by this common denominator over itself. So I'm multiplying by 1, I'm not changing anything. And the reason why I do so is to clear out, I want to clear out this fraction here and this fraction here, and so it is multiplying by the LCD across the two fractions that forces that to happen. So now we'll go ahead and we'll distribute this LCD to both of these terms in the numerator, and we'll also distribute it to the denominator, or multiply it through the denominator, however you want to look at that. So in the denominator, just to do that part, we'll just have whatever it comes out to be. So this will be h times the quantity 4x plus h plus 1 times the factor 4x plus 1. So all I did was say, hey, I'm multiplying this to this to this. I'm not going to worry about simplifying that, folks. There's no reason to simplify that, because eventually we're just hoping to cancel out that factor of h. But in the numerator here, I'm going to first distribute this common denominator. I'm going to first distribute this common denominator to this term. When I do so, the factors of 4 x plus h plus 1, those two factors will cancel, leaving me with just the 3 and just this. And so when I do that, I'll have 3 times the factor 4x plus 1. That was supposed to be orange. We'll have 3 times the factor 4x plus 1. Again, because I distributed all of this to this first term here, but these two factors canceled, and so I'm just left with the 3 and the factor 4x plus 1. So then what I'd like to do is I'd like to distribute this whole thing to the second term, and when I do so, now it'll be the x plus 1 factors that cancel, leaving me with a factor of 3 and this larger factor here. So when I do that, I'm left with the minus 3 factor. That factor remained. This factor right here canceled with this factor here, so we just have the 3 and this factor as well. So 3 times the quantity 4x plus h plus 1. So at this point, folks, we should be pretty much done with the problem. We'll just have some cleaning up to do. Let's go ahead and do so. in the denominator, because my whole goal is to cancel out this factor of h so I can apply direct substitution, I'm not going to do any distributing. So we'll just copy that through again. In the numerator, notice this is going to give me 12x plus 3. Then I'll distribute this 4 through and this minus 3. So that's going to give me minus 12x. And then we'll have minus 12h minus 3. And if we go ahead and cancel everything that cancels, by adding those out, we're going to be left with the limit as h approaches 0 of just, oops, folks, I made a mistake here. This should be an h factor right there. So again, I distributed this 4 through here, and then I distributed this minus 3 to everything, and that's how I got the minus 12x, the minus 12h, and the minus 3. Sorry about that confusion. And so then what we are left with is just minus 12h all over that denominator. And after we do so, the h factors cancel out, and by that I mean they divide out, and so then we're just left with the limit as h approaches 0 of, careful, minus 12 all over 4 times the quantity x plus h plus 1, all that times the factor 4x plus 1. And if I let h tend to 0, what we end up with is just minus 12 all over 4 times x, upright plus 0 plus 1, times 4x plus 1. But notice that because that's 0, I have a repetition of those two factors in the denominator. Many ways you could leave the answer, folks. There's no correct way to leave it, I guess. But this is probably a nice simplified way to leave that answer. So I think now, at this point, we've answered part A, which was to find f prime of x. So again, what did we find? So our answer to part A is that f prime of x is equal to minus 12 all over 4x plus 1 quantity squared. So if we look at part B asks us to find the equation of tangent line to the curve at a equals negative 1. So that's what we're told up here, right? Determine an equation to line tangent the curve at that point where a, we're told, is negative 1. So folks, I'm not going to draw an accurate picture here, but I want to give you sort of a rough sketch of what we're working with. Let me zoom in on that. I'm not going to give you an accurate picture, but let's give ourselves a rough sketch here, where here is the axes, and then let's sketch. So I'm not going to worry about sketching this exactly right, but let's say maybe our graph looks something like this. Here we have maybe negative, so here's negative 1, and then maybe we're going to have some sort of asymptote here. I'm not quite sure what's going on with this graph. We're just doing a quick rough sketch. Okay. So the point is that at the order pair, well, when a is negative 1, we want to compute the slope of the tangent line to the curve at that point. So our goal is to find this line. We want the equation of this line. Well, how are we going to do that? Well, normally, if you're tasked with finding the equation of a line, you would use the point-slope form of a line. We'd write y minus y1 is equal to m times x minus x1. That's where you've got the point x1 comma y1, so that's your point, and the slope is just m. But in our class, we're not going to represent the arbitrary point as x1, y1. That's how you did it in algebra class. Instead, oftentimes we'll use a comma f of a. So we would label this point right here, the order pair a comma f of a. And then instead of writing the slope of the tangent line, or slope of just an arbitrary line, we know this is this slope here. Even though we could call it m if we wanted to, this slope is the slope of the tangent line, so that's the value f prime of a. So our slope, instead of writing m, we'll write f prime of a. So if you can remember this, all you have to do is take this equation of a line and tailor it to be the equation of a tangent line. So this will be y minus f of a is equal to f prime of a times x minus a. So all we need to do now is figure out what a f of a and f prime of a are? Well, we already know a is equal to -1. We were given that. If we go to compute f of a, we go back to the original function. I believe that was 3 all over 4x minus 1. Let me just double check that, folks. That should be a plus 1. And if we were to, sorry, that's our function f of x. So if we were to compute f of a, which is the same thing as computing f of -1, this would be 3 all over 4 times -1 plus 1. And that gives us 3 over -3, or -1. And so this point right here, besides being labeled the ordered pair a comma f of a, could be labeled as -1, -1. So there's our point on the curve. Now the last thing we need to use this equation of the tangent line, the last thing we need is we need to know what f prime of a is. F prime of a would be f prime of -1, and we're going to take our answer from part A, which was here's the equation of the here's the derivative of this function at any point. We can then compute the slope of the tangent line. So we'll get that that is -12 all over 4 times -1 plus 1 quantity squared. And when I go to compute that, let's see here, that would be -12 all over, so that's -4 plus 1 is a -3 squared is +9. And that reduces down to, let's see, we can divide a 3 out of both of those. So that reduces down to -4/3. So the slope of this line right here, the slope of this green line we just found to be, so this is our f prime of -1, and we just found that to be -4/3. So, folks, you did not need to sketch a picture to do this problem, but you should know always that something like this is going on in the background whenever we're finding the equation of a tangent line. So lastly, we'll take that y minus f of a is equal to f prime of a times x minus a, and we'll just plug in what we know. So we would have y minus a -1 is equal to -4/3 times x minus a -1. And we can clean that up quite a bit, so that gives us y plus 1 is equal to -4/3 x, and let's do it like this first, x plus 1. And I'm actually fine with you leaving your answer there. I think that's a perfectly fine place to leave your answer, but we could go ahead and express it this way as well by distributing that -4/3 through. And if I clean it up even further, we would get y is equal to -4/3 x, and then minus 1/3, and that's a perfectly fine place to leave your answer as well. Oops, excuse me, folks. I made a slight error here, which I'll point out in the video. This should have been a minus. Let's make that in red so we can see that better. That should have been a -1 when I subtracted that over, and so then that would make that -7/3. And there we have the solution to this problem. I hope this is helpful. See you in the next video.